anyway, so everybody has seen quite a bit of information that's gone in, of course, the TCSI, and the information that is now feeding into the North Yuba. I will say that that's the tip of the iceberg, as there is a whole bunch of historical data associated with the Tahoe National Forest. There's, of course, all sorts of stakeholders that have their own information and desires and workflows they would like to see incorporated into a project that they are part of. So I had the enviable or unenviable task, depending on how much of a geek you are like me, with this, to try to compile all this and create a strategic framework that will ultimately support decisions on the landscape all the way through an actual NEPA document to implement. And so what I'm going to do is kind of highlight how we went through trying to figure out what was the most appropriate thing to use here and why. And I will say that there's definitely no right answer to do this, to stitch these different data sets and workflows together to come to a decision, but there are most definitely wrong answers. So it's an interesting way to navigate through these processes, and I'll try to highlight at least the big I guess decision points that we had to make in order to do that application. Before we do that, just real quick, I know we have some good background on North Yuba, but this just gets a little bit more into the nuts and the bolts. I'm not going to belabor the map here, but I will make this Prezi available to everybody, and you can dive in and surf around this information as you see fit. The first thing, of course, is that, yeah, it's over 250,000 acres. It's been relatively undisturbed since Comstock logging, and now as each of these fires on the west slope of the Sierra Nevadas take more of our large drainages, this North Yuba landscape is starting to be one of the last remaining continuously relatively undisturbed landscapes on the west side. So we're working feverishly to maintain what it does have to offer. So what does it offer? Well, there are some small communities, Downeyville, Sierra City, Camptonville. The majority of those communities are in Sierra County. Sierra County is one of the least populated counties and the least wealthy counties in the state. But that doesn't mean they don't have a lot of things going for it. One in particular is this watershed feeds the New Bullards Bar Reservoir, which provides electricity, water storage, flood control for the valley. There's, of course, a ton of threatened and endangered species, including Sierra Nevada yellow-legged frog, California spotted owl, American martin. And then it is a massive above ground and below ground carbon sink. Recreation, lots of it. A lot of hiking and biking trails. Those have ridden the Downeyville downhill, legendary ride. And of course, a lot of OHV routes and some great fishing. This is the organizations that made up the partnership. An actual MOU was signed to develop this partnership. And those include, of course, Tahoe National Forest, Circle, Nature Conservancy, Yuba Water Agency, which controls the New Bullards Bar Dam, Camptonville Community Partnership, Nisenan Tribe of Nevada City Rancheria, and National Forest Foundation, Sierra County, and Blue Forest Conservation. So in order to do the strategic framework, unfortunately, I wish it was, but it's not always as easy. Actually, it's never as easy as just plugging in some workflow and then aligning the data. In fact, I've done more than my fair share, both within the Forest Service and then in my private side of my career. And they're dependent on several factors. The first one, of course, is analysis, area size, and project scope. Folks are always asking, why are we doing something so complex or not complex enough? Well, it's really based on the area. If we're focused on, like in Sageham, 10,000 acres, developing something as intensive and data focused as this isn't as necessary because we can physically walk most of the ground and make appropriate decisions. But as the landscape gets larger, one human brain or collection of human brains can't consume all that data and make sound decisions without some analytical frameworks to help them. The other is the available data. The first thing I always ask is, what do we have? Ideally, it's comprehensive wall-to-wall LiDAR. Oftentimes it's not. And if it's not, then you have to adjust your framework based off of that. And then I always highlight the partnership technological capabilities and appetite. This is a big one, because if there are folks that are boots on the ground type individuals and they don't see the value in data or don't trust the data, or they don't have the technical aptitude to apply that data and make it make sense, then you have to tailor what you're doing based off of those capabilities. And if you're not being sensitive to that, there will be defection of the process, and that's the last thing you want. The other one is timelines. This is a classic one we had to deal with between TCSI and North Yuba, where essentially they were really on parallel tracks. And Nick showed some great stuff. Unfortunately, because the North Yuba was just a little bit ahead of what the TCSI was producing some of the products, we were only able to take advantage of a small piece of what TCSI did. Although we're always in communication trying to figure out, okay, can we plug in some of the stuff that has now recently come out into the framework? And can the partners understand it and are willing to consume it, even though it's new? And then policy and law. You can build the greatest strategic framework, but when it comes down to it, at least in this particular project, we are beholden to the Tahoe National Forest Plan, which really limits a lot of what we can do where. Now, there's an opportunity to rewrite that plan to a certain degree with forest plan amendments, but it's not a standard business as usual type of approach that we want to take, because the more changes to the forest plan you do, the more scrutiny it gets in terms of process. And I'm not going to dive into too much, but like I said, we're focusing on using the logic-based processing outputs from TCSI. We did use a heavy component of GTR 315. I know folks here are probably very familiar with that to try to determine risk. And we kind of turned it to also look at prescribed fire opportunity, because that's going to be a major player in the management scheme here. And then we're trying to use FORSIS towards the end to try to develop multi-objective trade-off analyses to help us understand where to go. We're going to have a good we're going to know very well where the priority areas are, but FORSIS is going to help us kind of coalesce those areas into projects and then determine which of those projects should be done first based off of all the input data we're setting up. And then, of course, like I said before, there's a certain degree of land allocations within the National Forest Plan and what we can and can't do there, even though we may want to reach NRV based off of HRV, for example, we may not be able to, because the forest plan limits those types of treatments in an inventory roadless area or a spotted owl pack. So zooming out, I'm going to bring in slowly, because it's overwhelming if you bring it all in at once, the strategic framework that I designed for this particular project. And then I'm going to dive into some parts and pieces just to show a little bit of detail. Obviously, there's more detail than we have time to go in here, but again, I'll provide this presently, so anybody that's interested wants to dive in, they can. The first, of course, is saying, okay, what kind of data do we have, the biotic and abiotic conditions, because that's where you want to start. And what those did is those fed the natural range of variability. And I say natural range of variability because we took advantage of two modeling efforts, as was mentioned before: historical range of variability and then the contemporary reference conditions. So kind of what would the landscape look like in the past? And then how does it compare to current contemporary reference conditions that have seen little vegetation management and lots of active fire? And then we've developed what we're calling SARAs. And for those that are steeped in GTR 315, it's basically HVRAs. We changed the acronym, one, because HVRAs, well, mainly because we had too many H's in R's and V's, but the other reason is that we are really trying to focus on the resources and strategic area side of things, which the HVRA template allows you to do to a certain degree, but this just kind of expanded and let our stakeholders understand that we're really focused on not just anthropogenic resources, but other places on the landscape. Of course, those current conditions and data fed in our fire simulations, which generated fire intensity and fire probabilities across the landscape. And this was using FSIM to stochastically produce probabilities. And then, of course, the natural range of variability gives us NRV departure, FRID, and then, as Becky said, biophysical class, which we transferred into biophysical unit, which is essentially quartiled those biophysical classes into four distinct areas. And then once we had our SARAs, our HVRAs, we needed to assign response functions from fire into each of those SARAs, and then the relative significance, which essentially helps us identify what is the pseudo value of all those things. And then all that together developed fire risk. We used FRID plus what was going on with SAR exposure and fire probability to determine where there might be opportunities to put fire on the landscape right now without some other management interventions. And then we also set up a bunch of other data sets, including the TNF land allocations, drought vulnerability from TCSI, and the general survey, which I'm going to dive into a little bit, and Becky touched on in HRV, as the package to help us ultimately prioritize treatments using the forces as a mechanism. And then as we're trying to, again, move towards developing a NEPA document, in this case, a conditional framework-based environmental impact statement, we used those biophysical conditions, those TNF land allocations, and the importance are the value of each of the SARs to develop desired conditions. We looked at the general survey, which packaged those data into nice packages, and then compared those, what is current conditions, to where we want to be, and that's how we develop those treatment objectives. The treatment objectives plus where we want to go first is going to go into our proposed action. And then we have a whole litany of other analysis that will need to occur between the proposed action and the EIS to ultimately develop a basic decision tree conditional framework that will ultimately be the EIS. And then ideally what we'll probably do is, as each individual projects pop out of this particular thing, those will be individual CEs or EAs, but that's getting into the NEPA law side of thing. But we're working through that right now. So with that said, I'll just quickly dive into some of these boxes. As mentioned before, the key piece of the North Yuba that really helped facilitate things, because we didn't have to stitch a lot of disparate, unnormalized data sets together, was the quality level 1 LiDAR that we took advantage of on the North Yuba. I will say though, as you see this date, 2014, it's already getting about 6 years old. And although we haven't had major disturbances, there has been some. So we took advantage of EDART, which is out of the Remote Sensing Lab Ecosystem Disturbance and Recovery Tracker, to identify which areas have seen change since 2014. And a lot of workflows in that to try to determine, okay, are we seeing a signature of deciduous trees, or is there real significant change in canopy of coniferous forest? But we distilled that into basically understanding which areas have changed since LiDAR was acquired. And if we felt comfortable and determined based on the metrics, we actually did adjustments of some of the metrics based off of EDART. The other piece that was really important is, of course, buildings, understanding where structures were. We also use BCM data to identify climate and few other things, but those were really the big ones. Real quick, the SARAs, or from GTR 315 HVRAs, this was a heavy process. Unfortunately, although there's lots of risk products out there, none of them get to this detail, and they just don't have the capacity to. But basically, we combed stakeholders, identified partners that had the data associated with what we thought was important. Everything from the county to identify what the emergency services were, where they were, communication towers, power infrastructure, water, where we actually did some modeling to determine sedimentation vulnerability and coarse woody debris vulnerability, but also infrastructure associated with that water delivery mechanisms, cultural sites, even mining sites, both active and abandoned mines, recreation, everything from trails to fishing sites, strategic fuel areas that weren't established in allocations like WUI defense, but large fire potential that we use from TCSI, established fuel breaks, community fuel reduction zones, and critical access roads, forest investments, and then ecological assemblages. And this was the challenging one, to try to figure out, okay, what is important and what is not getting captured already in the land allocation side of things from the Tahoe National Forest. For example, protected activity centers is already captured, so we didn't want to double count that here. But we developed several data sets. Some were just pure occurrence, like where are aspen stands, where are they not? Other times it tended to be habitat, which included some modeling. So all of that generated some information that we attach response functions to, which essentially, how do those SARs respond to different types of fire? And then we combine that with fire intensity to understand the exposure of each of those things. And that exposure could be good, i.e. that means there's benefit from fire, or it could be at risk from fire. So that's what you see here. So the other side of things is the natural range of variability. I'm not going to dive in because it's already been explained, but the idea is here is how we can combine these things to help us understand where we want to go. And we used natural range of variability for two things. One, we helped us identify risk and opportunity. And we used the NRV as a determinant of other pressures other than fire. So for example, if it was outside of NRV, then it had a lot higher likelihood of stand replacing disturbance from things like insects. So it kind of in conjunction with wildfire risk, it was really helpful to help us identify where insects might be an issue. But this is how we ultimately combine them. We use tree cover from HRV, tree density from contemporary reference conditions, as Kristen showed, where we're using departure, basal area departure in sage-hen, for example, and then tree development stage from HRV and tree size to ultimately develop, and Becky kind of showed this, areas where we are departed the most. And these areas where the departed are most are at higher risk of stand replacing disturbance. Oftentimes it overlapped with fire, but sometimes it didn't. And ultimately that fed into our treatment area prioritization. So that's really kind of the big picture. The other piece that I just wanted to highlight that I thought is critical, particularly when you're doing in the applied sciences field, is most studies, most scientific generated data is in raster format. And although that is very easy to perform analysis at some level, I have found that pushing that information into a vector package makes a lot of sense. And it is for several reasons. One, that is just traditionally how land managers have consumed spatial data. It makes sense to them. They understand it. They think of things in stands, packages of like conditions. And so if you're able to generate a package that is able to consume all of that complex raster data, you have a better chance of translation. But the other thing is a lot of times you wanted things to be analyzed at that vector scale. And the HRV is a classic example, is we couldn't really quantify departure without a stand boundary, a collection of similar stand attributes to ultimately package that information. Otherwise, you're just looking at it cell by cell and it's not that meaningful. So an initial step that we did is we generated what we're calling, in this case, a general survey or like a forest atlas that we used, that started from raw LiDAR, moved it into ecological workflows, and then generated this general survey, and ultimately made a very, folks that have seen stand vegetation maps very similar to that, but it was LiDAR based, so super robust in terms of the segmentation. But ultimately, this is just some of the metrics we included in that. You can understand the patterns, they make sense. And ultimately, we're able to receive all the disparate data sets and normalize them basically into that one vector data set. This is actually my favorite map I think I've ever made. We're able to actually see where the cost pools are that would support management, i.e. product benefits versus stands based off the treatment capabilities would have very little product benefit and would cost money. Of course, all of this information goes into the treatment prioritization and force it to ultimately help us understand where we get the best return on investment. So without going to each one of these boxes, which I'd make everybody go to sleep, I'll stop there and we can move on to our discussion side of things.